Welcome to the Artificial Intelligence Podcast with your host, Dr. Tony Huang. We're back here with one of our favorite AI SMEs, Babak Hodjat. Babak, welcome back to the show.
Great to be here again, Tony. Thanks for having me.
And for the audience who don't know Babak, can you just do a quick introduction about your background?
Sure, I am the CTO AI for Cognizant, run our R&D and AI strategy, and run our labs around the world. My background is in AI. I've been in AI all my career. It's all I know and all I've done. I have a PhD in AI. In a past life, I invented the natural language technology behind Siri. I launched the world's first AI-based hedge fund, ran the world's largest evolutionary computation run. I think it's still the largest. I've been through the thick and thin of AI when it wasn't fashionable, and right now burning in the spotlight, basically.
So there are a couple like topics that are some burning like questions for me, in which I think you can help us walk through and figure out like what's going on. Number one, I'd like to explore how DeepSeek really like upended the AI world a couple of months ago. And then number two is I'd like to dig a little bit deeper into multi-agentic systems. So to start off with, let's go over like DeepSeek. Can you just give us an explanation of what DeepSeek is? And then what they did that really caused like a huge media storm.
Yeah, DeepSeek is a model that actually came out of China, a Chinese startup. It's fully open sourced, including the technology that they use to distill and train the model. What was shockingly interesting about this particular model was the efficiency and how efficient it is to train it and how efficient it is when you actually run it, when you run inference on it. And larger language models are in the hundreds of billions of parameters and very difficult to train. You need data centers full of GPU machines to train them. And even when they're fully trained and you're just running inference on them, like you're asking a question off of GPT-4, it does take a lot of processing capacity, even when you're just doing a pass through the model for it to answer you. Now, the fact that I can run a DeepSeek model with 14 billion parameters on my MacBook M3 and get results that are on par with the GPT-4o mini, that is the scale of basically distillation, and I shouldn't say distillation, efficiency that they got to by doing some really tricky, interesting, creative optimizations on how these systems are configured and trained. The reason why it was a big deal, obviously, for those of us in the field, we did see this trend of models becoming more capable with more processing capacity, but at the same time, smaller models also becoming more capable. So there was a trend even with open source models and various different techniques. When you ask anyone in AI, they will tell you that they believe there is a lot of redundancy and a lot of space for optimization in these very large models. That's an area of inquiry. How do you make it smaller while not losing their capability? But this was a big step improvement. It was much bigger than people expected. And it came from China. So those two put together kind of shocked the system a little bit here in the US.
Yeah, I did remember when it got released that a big thing that happened was like all of the stocks that were from the AI vendors, like the biggest one would be like Nvidia. They saw
Mhm.
this huge price decrease, and
Yeah.
that kind of freaked out the market. Can you tell us like why people were freaking out about the DeepSeek and how that kind of affected a lot of the stocks in the States?
Yeah, there is this scaling law with models which says that the larger they are, the more capable they are, and we haven't really hit the ceiling yet. So when you speculate on stocks, you tend to look at that and go, okay, in that case, processing capacity and GPUs and the hardware that enables and empowers training and running these models will be in demand. And there is a shortage. Like NVIDIA, it's very difficult to come by their more powerful GPUs that are used for AI. And so the price is high. When DeepSeek came out, people realized that you can even train these systems, even run inference on them on CPUs, and they're still reasonable. And so that requirement for GPUs went down. That doesn't mean that DeepSeek itself was not trained using GPUs. It was. So it doesn't eliminate that kind of hardware. It just reduces the need for it. And again, to put things in perspective, DeepSeek is powerful, but it's not as powerful as the most powerful models that we have out there. So if you really want to do really gnarly reasoning and AI work, you would still go with those larger, more powerful, and more power hungry models. But it just pointed the way at the fact that you can have reasonably powerful and smart models that don't require the same amount of processing capacity. And that knee-jerk reaction was, okay, so maybe these stocks aren't as valuable as we thought. So that kind of is part of that. The other part was stocks for other large companies also took a beating a little bit because those were companies that were betting on these larger and larger models, whereas now you can have smaller, reasonable models. My personal belief in this, and we're going to talk about agents as well, is that there's a threshold beyond which a model is acceptable in its reasoning and natural language understanding. And for many use cases, not all, but many. And so in an agentic setting, if you pass that threshold, the model is acceptable. And from that perspective, you can see that there is a point where these models become commoditized for those types of use cases. And yeah, and that obviously anything that gets commoditized, there's a hit on its price.
Yeah, I'm so interested in your viewpoint on agentic systems. So let's switch topics over to that. And for our viewers at home, can you just very briefly describe what an agentic system is and how that's different from your typical naive way of using like a traditional chatbot?
Exactly. So when you're using a chatbot, if you're using a model, like a large language model, like GPT-4, this GPT-4 is a transformation. A model is basically a transformation. You give it some data in the input, it transforms it in some ways and gives you some output. So it's really doesn't have agency other than it just produces output. You give it an image and say, I don't know, make it 150 years older. It will take that image, transforms it so that it's 100 years older and gives you the data for that. Or you ask it a question, an inquiry, and it will respond and give you an answer. They're fascinating, very powerful, and their answers more likely than not are going to be useful, as we've seen with GPT-4, but they don't have agency. So if I tell a model, let's say, to turn on the lights, it's not going to be able to turn on the lights because it's just a model. It'll just know how to turn on the lights, but it won't be able to do that. We need some code that takes that intent of the output of that model and translates it into some call that will affect the world. In the case of this very, not that you would want to use GPT-4 to turn on the lights, but if you did, let's say you did have some API to turn the lights on, you would have some code that would view the output of the model. And if the output of the model said light parentheses on, it would know to read that, and that would trigger an actual call to the API that turns the light on and would turn the light on. There's some code there that's needed to make that bridge. When you empower a model with some code to be able to call tools, then we call that an agent at a very simple level. That's what we call an agent. And an agent has some agency because the large language model part can decide whether or not it wants to turn on the light or turn on music or do whatever you want it to do. If you have your home entertainment system here and you say turn on the lights, it will decide not to turn on the TV. It will decide. So it has some agency as to what to do and what not to do and in what order. Now, the example that I use is very simplistic, but you can expand it to, for example, your enterprise application suite that you use internally, the API or microservices that you have for all the processes and all the applications that you have within your company. And you can see that now you can actually place these large language models, these very capable models, with that extra code and give them a job description and say, you are responsible for my, let's say, supply chain management system. And here's the API for the supply chain management system. And I will tell you, I will give you some situations. Today we have this kind of a demand, or this is happening with our delivery system. And you make some decisions and make those calls to these APIs. and help me with the operating my supply chain management. Same thing would be your HR system, your intranet, your sales system, you name it. Anything that we can so mechanize and operate using software, we can now hand to AI agents to operate on our behalf. And what's really cool is that these AI agents understand language, which means that you can express your intent in a future-proof way. You can just describe it in English or whatever language you're comfortable with, and it will map that to the API call. So it's, as I said, it's a transformation. It's actually basically mapping your intent into some set of steps to take with the tools. So that's what everybody's very excited about these days, is the fact that you can now create agents that are custom built with their job description to do various different aspects of your business maybe or your personal life. Agents have been announced, for example, that can on your behalf they can go browse the web, click the buttons and go to various different URLs and find stuff for you and even do things for you. Anything that you can do on the web, this agent can do on your behalf. Just imagine what are the things you can do on the web. It's a lot. So your agent is actually able to do that. Now, that's agents and what agents are in a single agent. But the moment you start thinking about agents, you're confining them. You're giving them a job description and saying, this is the set of tools that you're going to be using. You're not a general purpose intelligence. You're an intelligence that is used for this specific set of tasks. And imagine you have another agent for another adjacent specific set of tasks. And rather than you deciding which agent to talk to, in many cases, it makes sense to have these agents talk to each other and coordinate and decide on what to do. So, in other words, in that set of tools that you give your large language model and you say, go operate them, one of the tools might be another agent. And what's nice is that this agent can talk to that other agent in natural language. Doesn't have to have an elaborate communication language. It could simply pass on part of the intent to that other agent. If I talk to my HR agent and I say my significant other has passed away, my HR agent can say, oh, significant other has passed away. I'm going to talk to the insurance agent, the payroll agent, maybe also to the legal advice agent, and see if those guys have a role to play in supporting me here. And each one might be actually taking part of that role. And then there's a consolidation that comes back and tells me, we're very sorry for your loss. Here's the set of things that you need to do. One response is what I get. So I'm dealing with one agent, but these agents are spontaneously coordinating with each other and coming up with what needs to be done. Because they're speaking in natural language, they can take any input, even if we haven't planned for it, and still be able to map it to the set of tools that they have at their disposal. One last thing I would like to say on this is that this is a shift in thinking in the world of AI. Up until recently, in the AI world, everybody's been thinking about creating a be-all, end-all model that is generally intelligent and can do everything. And that's because of the success of these large language models. But the moment you confine them to operating in a certain field with a job description and set of tools, you're actually empowering humans a little bit more. So now you're saying, oh, it's up to the humans to take this generally intelligent large language model, imbue it with some capabilities, and set it into some sort of a process or hierarchy or organizational structure and make it work. And I think that's a good thing. It's, for starters, it's practical and pragmatic, and we know how to do it since industrialization. We know how to organize and get stuff done with beings that are generally intelligent, called humans. So we can do that. And it also gives us some level of control over these systems, which I think is very good.
Yeah, I'm a big fan of multi-agentic systems, and I see a lot of value in them. If you go onto the news, a very popular company that uses agentic systems is like Windsurf. So they just
Mhm.
recently got bought by OpenAI for 3 billion, which is like a ton of
Oh,
money.
wow.
So when you were talking, the first thing I thought of as an example is like a coding assistant where it goes out and it uses these different tools such as searching the web or running something in terminal or like even just manipulation of the keyboard mouse in order to perform a task, that instantly was like the first thing I thought of because that's as a programmer, that's like the biggest value prop is like being able to offload all of these little minute tasks that I have to do, such as running ls to list a directory or like pwd, which is like present work directory to figure out where I'm at. I don't have to do that anymore because I have these tools that allow me to get rid of all these little repetitive dumb tasks that I have to do. So I love the fact that agentic systems are able to use these tools to like help accelerate solution development. So you guys at Cognizant, you guys have been developing your own agentic system, right? Can you walk us through what you guys built?
Yeah, absolutely. So what we've built is a agentic system that is very simple to set up, and you can create these prototypes very quickly because the definition of an agent or multi-agentic system is all in data. So it's a configuration file. It's called a HOCON file, where you can actually basically say, I have this agent that is the, let's say, the call center representative agent, and a down chain to it, it has a returns expert, and it has a upsell expert, and it has a support expert, and down chain to those guys are some others. And all of that is one file. And the description of agents are typically in natural language. You basically say, here's what you do, here's your job description. It's all in language. And so basically in that HOCON file, you very simply declare who's the top agent and what are the down chains to that agent. And then you go down through the file and say, for this agent, here are the down chains to that agent. And it comes with a very powerful coordination mechanism, inter-agent coordination mechanism, that allows these agents to spontaneously form teams as different situations present themselves and identify which agents need to play a part in responding. So you can extend it very easily. You can write Python code and what we call coded tools. So you can actually have these agents make calls into code. So you can go from the large language model to code and actually from code back to an agent. So you can have these hops between code and agents. That's very useful. And it has a number of other features. We've created multi-agentic sample systems that you can use to create multi-agentic systems. You just describe the system and what it's supposed to do, and it generates a multi-agentic system based on that description that could be a good first prototype for what you need to do. It's interoperable, supports MCP, which is this new protocol. For example, for controlling your desktop, you can have an MCP server and have an agent talk to it so that you enable the agent. Same thing for any other system that you have. You can actually create these MCP servers. Google also has this agent-to-agent protocol, so that's supported. There are a number of other agentic systems like Salesforce.com has Agentforce, Google has AgentSpace. We're interoperable with those systems, so you can make calls from these agents to third-party agents. And in the case of Agentforce, you can even make calls back. And this, one of the very interesting implications of the way we've designed this system is it allows you to very explicitly decide which part of the job description of this agent needs to happen autonomously by the large language model part and which part is in code. So you can basically decide, okay, there's some rules I need this thing to always follow. And large language models aren't very consistent and they aren't that reliable when it comes to that sort of thing. So it makes more sense for those rules to be written in the code part of an agent. But then you might say something like, I have this reasoning that I need to do. And large language models are very good at reasoning. So this part of the job description of this agent, I will rely on the reasoning part. And because the way the agents communicate with each other is through two communication pipes in our system. Our system is called the NeuroAI Multi-Agent Accelerator, and the libraries behind it is called Neurosun. And there's two communication pipes going between any two agents. One pipe is the agent talking to the agent, so the large language model talking to the other large language model, which is basically could be natural language. Anything goes. You can just, it's a set of tokens that one agent sends to the other, and the other might be sending some responses back. The second pipe is out of the control of the large language model, and that's really key. The second pipe, communication pipe, sends data structures back and forth, and they're always sent back and forth. So if one agent is working on some part of some output, it can place it in that data structure, and then that data structure will end up being sent to the other agent. And the other agent can now work some other part of that data structure. This is really important. You use the example of coding. When we write code, we might be writing a very large code with, let's say, it's a soft piece of software with many different modules. If we end up getting these agents to write that code, we will have to have the agents send the entirety of that code and all the files over every time to one another through that first pipe if we don't have that second pipe available. And that's subject to hallucinations, recall issues. It might actually forget part of the code as it's sending it to the other agent. And so it really limits how much we can actually use multi-agentic systems. But if you have that second pipe, then each agent can actually just make some changes here. Like, oh, I'll load this file and it'll make some change to this module and I'll put it back into the data structure. And the data structure is what is being served up across the agents anyway. And so that really makes it much more practical and allows us to always have that mindset of, okay, what is it that I'm delegating and what is it that I'm not? And what I'm not delegating has to be in the code, or maybe the code then makes a call to a human for a human in the loop. Last thing I'm going to say is that the system is very scalable. We've used it internally for several of our internal software systems. You can have multi-agentic systems running different large language models per agent. The entire thing could be running on one server and then making calls to some other agents on a different server. So very flexible package, if I may say so myself. I'm very proud of it, and we're using it a lot.
For our viewers at home that would be interested in learning a little bit more, what's the best way to contact you?
Yeah, so contacting me, obviously, you can hit me up on LinkedIn, Babak Hodjat. I'm on LinkedIn. And follow me on LinkedIn. You'll see a lot of this material there, and we are working towards a very big announcement next week around this software package that I talked about. So stay tuned with that. Hopefully, you'll be able to learn more about it through these announcements. And please reach out to us if you need help with your multi-agentic system. Cognizant is not a product company. We're not a software company. So we're not really licensing software to people. It's our expertise that we bring to the table. We wrote this package simply because we were not seeing these capabilities that we needed for our own implementations out there in any other platform. So we actually developed it ourselves.
Babak, thanks so much for being on the show. Always awesome to get you back and get your expertise on the topic. And to our viewers at home, stay curious.